Right, so in this video I'm going to have a look at graphing some functions, tangent functions. I'm going to have a look at graphing tan of theta, tan of 2 theta, and 2 tan 2 theta. So let's have a look at that. We're going to have a look first of all at just graphing the tan of, we're going to have a look at graphing the tan of theta. This is theta out here, our angle's theta here. So let's just fill in a few points here. I put in 0, I put in pi and 2 pi. So this here would be, let's say, pi over 2. It is pi over 2 in fact, and this here would be then pi over 4. This would be this 1 pi over 4, 2 pi over 4. So this here would be 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2. So this is 5 pi over 4, 6 pi over 4. This is 7 pi over 4 here, and then we're out to 2 pi. And I'll put in a minus pi over 4 here. And actually I'll put in a minus pi over 2 here as well. Okay, so there we go. Now, let's have a look at plotting a few points. So let's plot 0 first of all. So 0 degrees. Well, the tan of 0 degrees is just 0. Now, what about pi over 4? Pi over 4, 45 degrees. 45 degrees, the tan of 45 degrees is 1. So we put a point here at 1. Now, what about pi over 2? Well, what you find is pi over 2 is not defined. So why is that? Well, if you take, say, an angle theta here, this is my angle theta here, this is my y, this is my x out to here. The tan of this angle here is y over x, opposite over adjacent. If I make theta a bit bigger, so this is a little bit bigger angle theta, y has gotten a lot longer, x has gotten a lot shorter here. If I increase theta to 90 degrees, so straight up here, like this, or pi over 2, y is very big, and x has become 0. X has become so small that it's 0 here. So the tan of 90 degrees here would be y over 0. You can't divide by 0, it's undefined rather. So all along here at pi over 2, there will be no y value for my function. Okay, and that actually repeats every pi after that. So here out to 3 pi over 2, or 270 degrees, it's also undefined. It's also undefined out here. So up along here at 270 degrees, you can't get the sine, or sorry, the tan rather, you can't get the tan of 270 degrees either. Okay, and also here at minus pi over 2, it won't be defined either. So we can draw a line down along here to show that the function will not cross this line. There will be no y coordinate at this point here. So look, we've got pi over 4 is 1, and minus pi over 4, in fact, will be minus 1, so there'll be a point here. So what you end up with, in fact, is a curve that looks something like this. Goes down through 0, down through minus 1, and down along here like this. And remember, it doesn't touch this line here, so this continues on up along here. It gets closer and closer to these green dots, but never actually reaches it. And it's the same here. I mean, this thing here goes on forever in this direction and this direction, and we'll have a point here at 1. We'll have a point, sorry, not there actually, it'll be, I'll move that over a little bit. We'll have a point here at 1, and we'll have a point here at minus 1, and our graph again will look something like this. Okay, and that repeats over and over again. So in this case we have a period. We have a period for this graph of pi, and the range of this particular graph is from minus infinity to infinity, because these graphs go on forever. It gets closer and closer to these green lines, These green dotted lines would never actually reaches them. These green lines, by the way, are just called asymptotes. Okay, so that's our graph of tangent function. Let's have a look at the tan. What did we say we were going to do? The tan of 2 theta. So let's have a look at that. The tan of 2 theta. So this is the tan of 2 theta. This is our theta here. So what do you think would happen here based on what happened when we looked at sine and cos? We would expect everything to just squash in again, if you like. So what I'm going to do is I'm going to call this pi. This pi over 2. This is pi over 4. This is 1 pi over 4, 2 pi over 4, 3 pi over 4 here. Okay, so let's see what would happen here. Let's take 0. So if I put 0 in here, I get the tan of 0. So that's still going to be 0. Let's take pi over 4. So I want, first of all, the tan of twice pi over 4. So that's just the tan of pi over 2. The tan of pi over 2 is undefined. The tan of pi over 2 is undefined. So the tan, so here what's going to happen is we're going to have an asymptote here. Remember in the previous one we had an asymptote at pi over 2. Now we're going to have an asymptote here at pi over 4. So let me get rid of this. So we're going to have an asymptote here at pi over 4. So we're going to have a line down along here where the graph doesn't exist, if you like. Okay, now, so this would be pi over 8 here in the middle. So we'll just put a pi over 8 here. Pi over 8. Let's try that one. Tan. So we want the tan of twice pi over 8. So that's just going to be the tan of pi over 4. We know that tan of pi over 4, tan of 45 degrees is 1. So we should end up here with a point here at 1. This is going to be minus pi over 8 here, and we would expect a point at minus 1 here. And let's just stick in a minus pi over 4 here. So again, we would expect the asymptote to be down along here through that, all the way down along. So you can see the way our function will look if I just plot that in here. So it's going to come down along here, it's going to come through the origin, through this point here, and back down along here. And that's going to repeat as I go along here. So it's 1, 2, 3, 4. Let's say 1, 2, 3, 4. So I'm going to have an asymptote here as well. Okay, so I'll just draw that in here. So that's going to be up along here, down along here. And I'm going to have another function, another part of the function rather. Here it's going to come down through 1, through 0, and back down again here. Whoops. You get the idea anyway. So that's going to repeat over and over again. So what did we end up with? We ended up with a period of, remember this was 2 theta this time, so our original period for the tan of theta was pi. So this is the period for tan, the period for tan of theta is pi. So the period for tan of 2 theta is half of that, or pi over 2. And you can see that actually if you take, say, this point here, you have to go out pi over 2 to see that repeated. Any point here you'll see repeated after pi over 2 on the x-axis. So what's the range then? Well, the range still goes from, the range doesn't really change here. You're still going from minus infinity to infinity. It's still going off in both directions on the y-axis. Okay, so let's have a look at the last one then. We're just going to have a look at 2 tan 2 theta. So let's have a look at that. So we're going to look at 2 tan 2 theta. Now, I'll just change these thetas on the x-axis. So this is my theta here. So let's have a look. We'll start with 0 anyway. So if theta is 0, twice theta is 0, so twice 0 is still 0, so we're still going to end up here. Let's take pi over, let's say, what did we take up here in this one? We have pi over 8, let's say pi over 4. So let's start with pi over 4 here and see what happens. So this here is pi over 4. We'll take this as pi over 8. 1 pi over 8, 2 pi over 8, so this is 3 pi over 8, 4 pi over 8, or just simply pi over 2. You've got a 5 pi over 8, and so on. Okay. 6 pi over 8, or 3 pi over 4. 7 pi over 8, 7 pi over 8, and then 8 pi over 8, or just pi here. Okay, so let's try pi over 8. So we want 2 tan 2 pi over 8. So that'll give me twice tan pi over 4. So the tan of pi over 4, or 45 degrees, is, I'm going to change this as well. I'm going to change this, by the way, to, we'll change this to 2, we'll change this to 1, we'll change this to -1, we'll change this to -2. And you'll see why here. The tan of pi over 4 is 1, so twice that is going to be 2. So here we're going to end up at, instead of 1 here, we're going to end up at 2 for pi over 8. And it's going to be the same here at minus pi over 8. You're going to end up at -2 down here. So I think you can see where this is going. If we take pi over 4, so let's say tan, we've got 2 tan twice pi over 4. So that'll give me twice tan pi over 2. Pi over 2 is 90 degrees. It's undefined. Tan is undefined at pi over 2. So we're going to have an asymptote here going down along here through pi over 4 this time. And if we take minus pi over 4 here, we're also going to have an asymptote down through there as well. So you can see what happens here. We end up with a function that looks something like this. Okay, I'll show you exactly what this should look like in a minute. My drawing is not very good here, but you can see what's happened here. We still end up with the same period here. We end up with a period here of pi again. Okay, so the period here is pi, and the range, we're still going from minus infinity to plus infinity here. Okay, so let's have a look at this done properly, if you like, or accurately. This is what tan function should look. This is what your tan function should look like. A lot better than my drawings anyway. So you can see this is just tan of x here, or tan of theta. So you've got 0, tan of 0 is 0. This is pi here, so this is pi over 2 here, so it's undefined. So this blue dotted line here is the asymptote, okay? And that repeats. It repeats every pi. So you can see here we're at 0 here, and pi later on the x-axis we're still at 0, 0, 0. Every time you add pi on the x-axis, you get a repeated 0 y value. And that goes for all of these points along the red function line here. Okay, so that's it for tan function.